Hey, good morning, everybody. Thank you for joining us this morning. Looks like it's 12 o'clock now. We're going to wait a couple more minutes for some more people to show up, and then we'll kick this off. Thank you for joining us. All right. Good morning, everybody, or good noon, good afternoon, depending on where you are. We're going to kick this off. I think we still have a few attendees arriving, but with no further ado, I think we're going to kick this off. I'm Jeremy Orr of Renew Wisconsin, Emerging Technology Program Manager, where I focus on electric vehicles, building electrification, and some other emerging technologies. Hope everybody's having a great day today. It's Friday, and what a way to end the week with a webinar on building decarbonization in Wisconsin. We have an expert team of panelists presenting today, and we hope you walk away with a better understanding of building electrification. So just a quick agenda, what are we doing here anyways, right? So I'll provide a very brief introduction on beneficial electrification, and then we'll roll right into our panelist introductions and presentations. And at any time during any of the presentations, feel free to type away in the chat box any questions you might have for generally for a panelist or for any specific panelist. And we'll have about 10 to 15 minutes at the end to sort of field those questions in a timely manner. So feel free, chat away, ask your questions. And with that, let's kick things off. So beneficial electrification, what is this mysterious term we all hear thrown around daily, right? Well, it's the replacing of direct fossil fuel use with electricity in a way that reduces overall emissions and results in cost savings, right? And some would even add enables better grid management, and others would still say you have to have just one of those prongs, for instance, like cost savings, without negatively impacting the other prongs. But for the most part, you'll see the end user cost savings and reducing emissions. And we talk a lot about transportation electrification and how it relates to beneficial electrification, how it reduces emissions, the cost savings for the end user, and all the other EV policy and legislative items, market items out there that we discuss daily. And rightfully so, as we can see here in this chart, the transportation sector accounts for a very large portion of Wisconsin's emissions, right, at 24%. Well, let's not forget the emissions of the building sector as well. Taking into account residential, commercial, and industrial, we're still at 24% direct emissions in the state of Wisconsin. So we've got our panelists here today, this expert team, who will be talking about how the building sector can help reduce those emissions. What are the opportunities for building decarbonization? How can we leverage a cleaner grid to produce favorable results like beneficial electrification, right? What's the connection between electrifying the end use with renewable energy sources? Which can be applicable both to transportation and building sector electrification. And how can we produce more equitable results in the building sector and just some other, technologies available to electrify buildings and some other policy items. So hopefully you all came engaged and ready to learn. It is, after all, Friday, so you can walk away from today's webinar, maybe impress your friends and family this weekend with all your newfound building decarbonization knowledge. So let's kick it off with our panelists. First up, we'll have Lauren Reeg of the Rocky Mountain Institute. Lauren specializes in carbon-free buildings, and she'll be talking to us today about how to leverage a cleaner grid and how that can produce favorable results like beneficial electrification. She'll be followed by Marnese Jackson. Marnese is the co-director of the Midwest Building Decarbonization Coalition. Marnese will be talking to us about how to produce more equitable results in the building sector. She'll be followed by Michael Barnett. Michael's with HG Architects and Engineers. Michael's going to talk to us about some of the building electrification technologies, as well as some of the barriers and opportunities, and just making that connection between beneficial electrification and renewable energy sources. And then we'll be anchored by Scott Niesen. Scott is the director of the Wisconsin Geothermal Association. Scott's going to tell us more about heat pumps in Wisconsin, as well as some other policy and education items. And then, of course, you know, just as a housekeeping side note, again, if you have any questions during any of these presentations, please feel free to text your questions in the chat box, and we'll short field those at the end. So with that, I'm going to stop sharing my screen and kick it off to Lauren. It's all yours, Lauren.
Thank you. Can everyone see the slides? Is that looking good? Awesome. I'll assume no one's saying anything is a yes. All right. Hi, everybody. My name is Lauren Reeg. I am an associate at RMI, and I work on carbon-free buildings on the Midwest campaign. RMI has worked on moving the national building stock away from fossil fuel for over 40 years, and we're working to achieve a climate-aligned future. We now have over 400 people and are located across 5 US offices and 3 international offices. Specifically on the Midwest campaign, we are working with cities and states throughout the Midwest to electrify the region's building stock through policy advocacy and federal funding support. So what are we talking about today? We're talking about building decarbonization, and it is a hot topic. It has been filling the headlines of news sites for years, and it's time that we really start talking about it here in the clean energy space. When we talk about buildings, we talk about 3 sources of emissions: direct, indirect, and embodied. Embodied emissions are the emissions that come from the building structure. For example, if you have a building made of concrete, the emissions that it took to make that concrete and then put it into the building. Indirect emissions are from the electricity used within the building, and direct emissions are from the gas or fossil fuels burned within the home. So I got some good news and I got some bad news for us. The good news is that indirect emissions like electricity has decreased because of additional renewable energy and efficiency on the grid. We can see from this slide, since 2007, electric power has reduced its emissions by about 40%, whereas we see that the emissions from buildings, specifically direct emissions, has really seen almost no change. And so this is important to understand that direct emissions and then embodied carbon emissions have largely gone unaddressed, and it's time we start doing something about that. Today, we're going to talk about direct emissions for 2 main reasons. One, because I just said that they've largely gone unaddressed, unlike indirect emissions. And 2, they have some really dangerous human health impacts that's important to talk about. And then the final reason is this is really important to Wisconsin. Wisconsin is the 11th largest contributor of direct building emissions nationally. And so that's something that the state really needs to consider. What we're going to be talking about: what does building electrification look like? What are some of the benefits? And then we're going to address a couple myths. So building electrification means converting a building system that uses fossil fuels like gas, oil, or propane to high efficient electric equipment that can be powered by increasingly clean and renewable electricity. Although electric appliances do still produce emissions from power plants that produce the electricity, the grid is becoming cleaner as we expand renewable energy, and Wisconsin is doing a pretty good job of that. In addition, electric technologies remove all the direct emissions from buildings and can help greatly improve human health. But practically, what does building electrification look like? Well, you're going to have to replace some appliances. Some of these changes will include replacing a gas furnace or boiler to an electric air source heat pump, a natural gas water heater to a heat pump water heater, a gas range or stove to an electric induction. Now, I do want to make one point. Electrification does not include electric resistance technologies. The point of electrification is that it is efficient and electric. If it's not efficient, then this cannot be an affordable transition, and that is a key to electrification. So now that we kind of know what building electrification is, why do we want it? What are the benefits? Well, First are the climate impacts. Wisconsin has a huge amount of direct emissions. About 17% of Wisconsin energy-related greenhouse gas emissions are from burning direct fossil fuels in the home. And this is something that we can address by addressing direct emissions and building electrification. For many years, people have wondered, are electric appliances also more climate friendly than the gas alternatives or highly efficient gas alternatives? And the answer is yes. We can see here what this slide is saying is that heat pumps reduce carbon emissions versus a highly efficient gas furnace in every state except one, and that is not Wisconsin. Wisconsin will see carbon emission benefits, which proves to us that we need to start installing electric efficient heat pumps and other electric appliances now. Now, why do we know this? Well, we've been able to do this because Wisconsin has had such good benefits on clean energy. Wisconsin has been installing hundreds of renewable energy installations across the state. You can see from this map right here, these are all the non-residential renewable energy sites in Wisconsin, and it's a lot, and that's why we have such a clean grid. And yes, it has a long ways to go, but this clean grid has allowed heat pumps to be more carbon friendly than efficient gas appliances. We also expect this to just get better. The governor has been doing great stuff. He announced a goal of 100% clean energy by 2050, which means that we expect that heat pumps and other electric appliances are just going to get cleaner and cleaner. Another benefit of building electrification is the health aspect. Direct emissions cause pollutants like NOx, particulate matter, and other emissions that are burned directly in the home, whereas electric appliances do not. This is pretty scary for me because indoor air pollution is unregulated, unlike outdoor air pollution, which means that just baking a cake or boiling water can lead to your house having higher indoor air pollution than what would be legal outside. And that's pretty scary when on average, we spend about 90% of our time inside buildings. So those are some pretty scary numbers. But building electrification and decarbonization can really help. There's some big benefits like less exposure to harmful appliance pollution, both indoors and outdoors. There's fewer safety concerns because without gas in your home, there will be less leaks, explosions, and fires. And I can't speak for all of you, but I personally prefer no explosions in my home. And then third, improved thermal comfort indoors and outdoors. With efficient and affordable space heating and cooling, you can have that your temperature in your home be exactly what you want. Or maybe if you have other people in your house, you guys can argue about it, but it won't be your appliance's fault. The next benefit is cost. Heat pumps and other electric appliances can be super cost effective. So electric appliances like heat pumps are cost effective in almost all new construction because you can avoid the gas infrastructure you'd have had to put in order to put gas appliances in. For electric resistance or delivered fuels, these are also more cost effective because these are generally either expensive fuels or have very low efficiency. People with electric resistance or delivered fuels can see up to $453 per year in savings. And then finally, you also see cost savings from avoiding gas infrastructure. So having to put gas pipes into your home and avoiding the cost of health and emission impacts. The last big benefit we're going to talk about is jobs. And I know that jobs is a super hot topic in Wisconsin, as it is everywhere. Well, right now, Wisconsin has about 70,000 clean energy jobs as the end of 2020, with 56,000 of those jobs coming from energy efficiency, which is the backbone of building decarbonization. Electrification would add about 4,500 installation jobs directly within the state. And nationally, electrification could add 80,000 manufacturing jobs that Wisconsin could compete for. So those are some pretty awesome benefits. I think building electrification sounds great at this point. I think the next thing we're going to talk about is myths. So there are some things that are big misunderstandings that I'd like to clear up today. First one is that they work in cold climates. So historically, people have thought that these types of appliances cannot work in cold climates because they need heat from the outside. Well, that might have been true a decade ago, but it's no longer true. Technological advances have finally allowed heat pumps to perform in cold temperatures, staying as low as -10 degrees Fahrenheit and still operating well. They can also operate at more than double the efficiency of resistance or gas systems, and they're affordable. These aren't just manufacturing claims too. Heat pumps have been successfully field tested in Minnesota and even the Arctic Circle. So our Arctic animals say yes to heat pumps and electric appliances. The next myth I want to talk about is alternative fuels. There are alternative fuels like hydrogen, biogas, and RNG that are capable of being carbon neutral or low carbon. However, these alternatives are often more expensive than electrification and do not eliminate the health impacts of direct emissions within the home. Additionally, RNG isn't a viable alternative to gas because it's expensive and there's also not as much gas as what would need. Even in optimistic scenarios developed by the American Gas Association, at most 12% of US demand can be met by renewable natural gas in 2040. With this limited supply, we think that this gas should be used for the hard to electrify industries like sectors like the industrial sector, and that when possible, we need to electrify. So we're going to end here. We're here because of a climate emergency, and scientists say we have an urgent deadline. In the building sector, this could require Wisconsin retrofitting 5% of buildings every year. And I know that number is really scary and seems like a lot, but we've done it before. In the mid-1900s, our main source of heating was coal. And now I know 0 houses or 0 buildings that have coal, and there are very few that do. So we've made that transition once, and it's time to make that transition again to make electric technologies the leader in heating and cooling our houses. So with that, I will say thank you, and I will hand it back off to Jeremy.
Thank you so much, Lauren. Great presentation. Up next, we have Marnese Jackson. One second, Marnese. I will share your slides.
Thank you so much, Jeremy, and good afternoon to everyone. So I am Marnese Jackson, and I am the co-director of the Midwest Building Decarbonization Coalition. I am actually located in Michigan, 30 minutes outside of Detroit, and it's nice to be with everyone today. So I'm going to talk about what does achieving equitable results in the building sector looks like. So a lot of this will be in theory because when we talk about equity, a lot of people who will make this conversation equitable are not at the table. So a lot of this will seem in theory. However, there is going to be some things that you can put into practice. And so as we all know, building decarbonization is very urgent, right? We must reduce the health, safety, and economic impacts of climate change and air pollution. Equally important is how we get there. We must collaborate equitably to center environmental justice communities who have been ignored, polluted on, and pushed into unaffordable housing and debt. And so that I described is called intersectionality, because if you look like air pollution, the health impacts, affordable housing, and debt, people who have been pushed into these situations don't live one issue lives, okay? So let's keep that in mind as I go through this presentation. And we also must grow relationships and capacity to embody the principles of the environmental justice principles and transforming policies, markets, and buildings in Wisconsin. So keep that in mind. So in the next slide, this is the team at the Midwest Building Decarbonization Coalition. We are a growing team, and actually we got started back in 2020. So I wanted to give you a little bit of information about the coalition and what we plan to do to advance building decarbonization in the Midwest. So in the next slide, the coalition, as I stated, was founded back in 2020. And our mission is to pretty much build regional capacity to enhance and support existing state and local advocates to develop a diverse building decarbonization coalition with equity as a primary focus. This is an 8-state region, as you can see, across the Midwest. And yes, you see Wisconsin is in our priority states that's highlighted in orange. So we are choosing to inspire and educate Midwesterners to end new installations of fossil fuel equipment in residential and commercial buildings by 2030, right? That's very ambitious. And we don't have enough time, right? And to achieve zero emissions from these buildings by 2030 with the intentional and consistent integration of equity and labor justice across all facets of our work. And so how we do that? Equity, we have this regional structure that supports strategic gaps in development, education, and training of our allies to fill those gaps. And we have actually one of our partners, RMI, on the line. So thanks so much for collaborating with us. And we're going to do that by advancing policy as a regional structure. We support strategic analysis and create opportunities to make sure that we accelerate deployment of technical assistance. And we're going to do that by market transformation, which is industry and utility energy efficiency and heat pump collaboratives, mostly frequently and efficiently at the regional level. And then provide research around job and economic development, right? Because we want to create new, clean, electrified jobs for people who want to switch from dirty fossil fuels. So that's a little bit about the coalition. In the next slide, our theory of change, just a little bit. There has been no comprehensive plan to eliminate building sector emissions in the Midwest. And so no organization was doing a regional strategic building decarbonization advocacy plan. So of course we invite you to our coalition to be a part. I wouldn't be myself if I didn't do a shameless plug, because right, we need people here to make sure that we advance equity, housing, strategic policy in the coalition. And so what is equity? In the next slide, as you can see, some of us may have seen this picture of what equity is. The reality is that there's people at the bottom and who needs to have a step up, and that's called equality. As you can see in the second photo, that's the equal playing field. However, equity is lifting people up to make sure that the people at the bottom are rising to the top so they can really have an equal foot at the table. And hopefully one day we'll get to liberation where we won't need the boxes, right? So equity, environmental equity is a basic human right. Environmental justice is the fact of protecting that right. Environmental justice involves the action and activism necessary to highlight inequities and level the playing field. This means proper oversight and review of federal policies, proper permitting and licensing for companies, buildings, and warehouses that emit pollution, setting clear standards, regulations, and laws that protect at-risk communities, and awarding grants to organizations that act on behalf of these communities. And so, yes, we are doing that. And so according to the EPA, environmental equity can be broken down into two categories: fair treatment and meaningful involvement. And meaningful involvement means that groups can offer input regarding decisions that affect their health of their environment. And this involvement also means that their input will be taken seriously and considered when making these decisions. And lawmakers will actively seek feedback from these affected communities. So this is the first step if we want to have equitable decarbonization results. So in the next slide, I just wanted to outline this. If your organization is seeking to be more equitable, redistribute the funds that you receive from foundations. We are doing that in the coalition by having a regranting and participation stipend where we allocate 40% of our funding that we receive from McKnight Foundation and the Energy Foundation to communities who are not necessarily in this field of work, okay? So that's an example of how we're doing that. In the next slide, an example of how we're moving things forward with our participation stipend and regrant program, we are creating equitable policies across the coalition so we can make sure that we're not operating in a structure that is harmful or a white supremacy culture type of way. we're having an equity summit of how we're going to do that across our different work streams and our technical streams, because we're aligning technical framework with equity framework, and it can kind of be the clash of the titans, right? So we're having this equity summit that, of course, I invite you all to in November, so we can get on the same page, because this is a regional structure and we want to make sure that we are at the forefront of being that. And then we also provide EJ trainings, because everybody is not coming to this field with the same knowledge of environmental justice, climate justice, utility justice, energy justice, right? So if you're ever interested in that, you can reach out to me. So in the next slide, what is equitable decarbonization? And I know Lauren went over the definition of building decarbonization and electrification. Building decarbonization means converting appliances like stoves, water heaters, and furnaces, water heaters from fossil fuels to clean, carbon-free electricity. Simple, right? Equitable building electrification is an effort to incorporate racial equity and energy democracy into the process and policies being proposed. The goal to electrify buildings is the same. The key distinction is the process, people, and methods to achieve the goal, which will build community engaged solutions to clean our air, create healthier homes, create good jobs, right? Prevent community displacement like gentrification, and empower workers. And according to Policy Link, equity is just and fair inclusion into a society in which all can participate, prosper, and reach their full potential. Sustainability without equity is sustaining inequities. Next slide, please. So in this photo, in buildings, we notice this is what it looks like in our home, right? But to take it to get a sense of what this looks like in an equitable way, Black, Indigenous, and other communities of color nationwide experience disproportionately poor air quality. This is especially true in Midwestern states where non-white communities face some of the most disproportionate particulate matter burden, meaning communities of color are more likely to be exposed to hazardous pollution created by fossil fuel combustion. These disparities also are in metropolitan areas in the Midwest and other parts of the country. So this is important. I know I'm looking at this at a regional level, however, because that's what I do, but buildings contribute to this dangerous air pollution. Gas appliances like stoves, furnaces, and water heaters release carbon monoxide and other air pollutants, meaning they can have negative impacts on health. And so there was a literature review outlining that gas cooking had 42% increased risk of experiencing asthma symptoms. And so when we think about building decarbonization and equity, communities of color live are renters who may have access to gas stoves. And so that means that it's a equity issue, a racial justice issues, and also an economic issue. So in the next slide, how can we move towards being more equitable and building decarbonization? First, we can start with demonstration projects. I know this is small, but communities of color and low-income communities needs to see what electrification looks like in their community. Yes, this may not solve taking down a big utility conglomerate. However, this builds movement of people to push past these different polluting facilities. And so this is an electrification project in Pembroke, Illinois, where there is also a dirty gas pipeline, NICOR gas pipeline that is going through that community. So yes, the gas pipeline can bring jobs, right? However, at what expense? The expense of people's health. And who community is that? That's a Black community. So I wanted you all to see this because this is an opportunity to show what you can do in the possibilities in a Black or brown community or low income community. However, this is also an opportunity to acknowledge that big polluting facilities will target low income Black and brown communities. So in the next slide, and this is a and I'm sorry, I'm kind of recovering from a cold, but in this slide, how can we equitably decarbonize buildings? Well, one, we have to make sure that we acknowledge that we can't use the same practices that our country was founded on. The landscape of the United States was founded of the displacement of indigenous people and was built by the enslavement of African and African Americans who contributed to building our infrastructure, right? So we can't use these same practices to advance building electrification policies, right? So as stated by Greenwashing Institute and energy efficiency all, while building electrification has promising benefits for residents, it must be pursued equitably, ensuring that environmental and social justice communities can benefit rather than being left with polluting and increasingly expensive gas appliances. It will require intentional policymaking and a planned transition for environmental and social justice communities to gain access to their major benefits of electrification, including cleaner air, healthier homes, good jobs, and empowered workers, and greater access to affordable energy and energy efficiency to reduce monthly energy bills. So there has been a lot of false solutions that have profited off of this sector, and we need to change the narrative of how we look of advancing policy in building decarbonization. So in the next slide, building decarbonization should just really create good jobs, pay fair wages, have job security, and also look at how we are advancing energy in our communities in the Midwest. So achieving the level of building decarbonization is very necessary, and we create millions of jobs in the Midwest. In the next slide, so how are we going to get there? We have to have healthier homes, address the energy burden, avoid displacement of people when we create these jobs, and creating good jobs, right? Sustainable jobs. I have to acknowledge that there is a national shortage of affordable rental housing in the Midwest, right? 31 to 45 available affordable rental homes per year are lower income households, right? And why is this important? Because when we think about the full spectrum of equity and building decarbonization, we also have to think about the people who live in these homes and who may not be able to get a home loan for whatever reason, right? So we're going to have more renters. In the next slide, we have to change the narrative. Repair, reverse, just repair, right? And we're all looking at this as an equity framework, but we have to think about facing these different, a lot of us may be in the policy arena, and we have these common languages like net zero or carbon neutrality. These often sounds very ambitious and may even give the impression that the world is awakening and ready to take on the climate crisis. We can make a transition. However, carbon neutral means that we are capturing as much carbon as we are emitting it. So there is a neutral balance of the carbon that is being emitted through all of the combustion of fossil fuels and wood-based products and industrial manufacturing. However, after we pass 2050, we have to start going carbon negative. We need to start sequestering more carbon than we emit. And that's the tipping point. And carbon neutral is only a goal into 2050. And we can only plan mid-century, and we need to shift to a new paradigm. So planning to go carbon negative by 2050 is definitely ambitious. However, a building can be carbon neutral if you have rooftop solar installations, solar panels on your roof. You are generating renewable carbon-free electricity. On a general climate level goal is a good goal. However, it's complicated. Building level, we want to be carbon-free. Net zero and carbon neutral balances out the system. And the system can be defined by these economies on the global or a single building. And so carbon neutral and carbon zero are kind of saying the same thing. And we must work to be carbon negative or zero emissions. So in the next slide, I wanted to talk a little bit more about that. because greenwashing is a thing and it's disinformation disseminated by an organization so they can present like they're being environmentally responsible. And so when I think about false narratives, false solutions like carbon net zero, building owners who claim that they are net zero can because they bought carbon offsets to compensate for their energy storage, that's where we begin to get into the false problematic definitions of net zero. They say that net zero by the future day by investing in development of some direct air capture technology that hasn't really been proven to capture this carbon into the air and put it underground. So this doesn't exist yet. And however, this is an example of a false promise and can be greenwashing. In some communities, this capture can also be pushed out to create fracking, which is also harmful to communities. So when we're thinking about equitable building decarbonization, we have to move away from these false solutions that may harm these communities. And so in the next slide, equity issues related to emerging building electrification policy agenda has not been sufficiently addressed. Despite the critical need. And so the equity questions are unanswered for one reason, because the equity advocates and impacted communities are not yet in the idea creation, right? They're not at the table. They're not the decision-making process. So to have equitable results, you have to get people at the table, right? City and regional planning processes need to engage with the community-based organizations, housing advocates, rental associations. And we also must understand that there's a capacity building and education building in that process. So it takes time. And some solutions are, one, in the next slide, assess the community needs. This should include understanding barriers preventing community members from electrifying their home, residents' knowledge levels regarding building electrification and their specific needs, wishes, and concerns. And so you must establish a community decision-making process, okay? Rich community input and engagement strengthen the overall program's design quality with stronger cultural competencies, okay? So have community organizations involved in your decision-making process. Develop metrics and plan for tracking. That only means that if you plan, develop, you make mistakes, you're going to get better as you go, right? Now, step 4, ensure funding and program leveraging. Make sure that you get access to these different programs that come down from the federal level. And so current and low income energy programs often fail to deliver maximum benefits because a lot of people do not know about it. It's a program design and it does not reach the customer. So outreach is definitely needed. And then lastly, improve the outcomes. We have to get away from this whole system of perfectionism. You can improve your metrics over time and consider adjusting your program when they come down from the federal and state level over time. So in the next slide, some other solutions to engage, of course, eliminate reliance on fossil fuels. We have to switch, and we have to, like, once again, change the narrative of saying natural gas to dirty gas because it's just dirty, okay? Fighting a power plant, passing a law, and these are some things that are simple, but they are obtainable. Advance the clean energy future, promote energy efficiency. Energy efficiency is accessible to low-income communities of color, and advocate at the Public Service Commission or your utility commission. And the next slide, this is very theoretical. However, you can put into practice. We all have been indoctrinated into the white supremacy culture. And these characteristics on the screen are very damaging on how we do our work. So when you're out doing your work and thinking about doing equity across building decarbonization, you have to make sure that you're not perpetuating these different characteristics. And the one that comes up the most for me when I'm doing my work at the Building Decarbonization Coalition is sense of urgency. Yes, we want to pass the law. Yes, we want to act on climate before 2030. We want to make sure that we advance in everything, but however, at what expense, right? People lives, not doing it the right way, not including people at the decision-making part. So I encourage everyone to definitely look these up because we all have been a part of them. And the solution to sense of urgency, next slide, which also means in an unfettered sense of urgency makes it difficult to take time to be inclusive, to encourage democratic and thoughtful decision-making, to think in the long term. So Black people, communities of color end up being the sacrifice zones in order to get the victories that most of the time white people really want to advance. So I say slow up, set realistic work plans. Leadership must understand that things may take longer than anyone expect, and that we have to make sure when we're setting these goals of involving people to be equitable, it has to definitely be inclusive, and do your homework in the beginning. Black and brown communities should not be included after the fact. Okay, so in the next slide, the climate crisis is not just about the environment, it's a crisis of human rights, of justice and political will. Colonial, racist, and patriarchal systems of oppression have created and fueled it, okay? And we need to dismantle them all. So our political leaders can no longer shrink their responsibilities. So we have to move from the extractive accounting, which we are doing, and move to the regenerative economy and making sure that everybody's involved in that process. In the next slide. So as I stated before, this is the spectrum of getting people involved in community or ownership. So this is the spectrum. Most of the time we do ignore the marginalized communities because we want to get things done, but we have to inform, we have to consult, and in your consulting phase, you have to make sure you do not tokenize the individual who you think will speak for the whole group, because we, Black and brown people, we're not a monolith. You must involve everyone and collaborate and defer to community ownership if you want to do equity. If you can't do this respectfully, don't say you want to do equity, because you want to do things in the right way. And so here in the next slide are some references to the NAACP Center Equity in the Sustainable Building Sector and the Green Lighting Report on how you can advance equity. So I am done, and I hope I didn't go over time, but thank you.
Thank you so much, Marnese. If you could just share. Actually, I was working it for you, so stop share. And next up, we have Michael Barnett.
All right, thanks a lot, Jeremy. I'm gonna pull up my slides here, just one sec. All right, well, good afternoon, everyone. I see a lot of familiar names and unfortunately not faces on the webinar. Thanks for joining. I think we're looking at the attendee list here. We're kind of preaching to the choir, so we're relying on you guys in the audience to take this message and share it with all the folks that you're working with on a day-to-day basis. I'm going to go through these pretty quick because I want to make sure we have time for Scott, and also want to make sure we have time for some panel discussion and questions. So I'm going to talk to you about electrifying heating in commercial buildings. Again, my name is Mike Barnett. I work for HGA Architects and Engineers. We're a national architectural firm, and we have an office in Middleton. Before we were acquired by HGA, we were a Sustainable Engineering Group, and that's how a lot of people still know the folks that work out of our office. Lauren covered a lot of this in her presentation, so I'm gonna just keep moving here, but I'm pretty much talking about heat pumps here today, and electric heat, as Lauren was saying, is
Hey,
really
Mike, sorry to interrupt. Are you sharing your screen, your presentation slides?
Yeah, do you not see them, or?
Not seeing them, no, sorry.
Oh, my bad, my bad.
I can share them if you need me to.
No, I got it, I got it.
There we go. Yeah, it looks like you're starting to share. There we go. Thanks,
Okay,
Mike.
that should work better. It should pop up here in a sec. There we go. How's that looking, Jeremy?
Good to go. Thanks, Michael.
All right, no problem. So yeah, today we're going to be talking about heat pumps, geothermal, water source heat pumps, air source heat pumps. This is another slide that I think Lauren covered pretty nicely, but the is that our grid is getting a lot cleaner. Right now, our CO2 emissions per megawatt hour is around 1,200 pounds per megawatt hour. And in 10 years, it'll be 30% reduction. And by 2050, it'll be 80% reduction. And this is just talking about the grid, right? If we have solar panels on our roof or out in our field, we're using a lot cleaner energy than what we're getting from the grid. So to help clarify this point, I did this little back of the envelope calculation here to show you a typical building and what it would look like with 3 different technologies for heating. So brown is natural gas heating, such as like a gas boiler or a gas furnace. Blue is air source heat pump, and green would be a geothermal heat pump system. So similar to what Lauren was presenting right now, air source heat pump in Wisconsin is going to have 8% less emissions. But as our grid is getting cleaner, right, by 2030, we're at a 36% reduction. By 2050, 82% reduction. So, working with our clients, why would we recommend a natural gas heating system if essentially by 2030, if they're getting all their electricity from the grid, they have essentially an outdated system or an obsolete system. So we really want to set the building up for success over the life of the system. So that could be 20, 30, 40 years. So we really want to have new construction be building with electrified heating system. Okay, to keep things moving, I'm not going to go through these bullet by bullet, but I think they're posting slides. So if you guys want to check this out later, go for it. Okay, so I'm going to get into some case studies locally in Wisconsin of where are we seeing heat pump buildings, electrified heating buildings. So this first one, it's actually just a year old, and it's a verified net zero energy building, verified by the New Buildings Institute. And this building is the Oregon Elementary School in Fitchburg. It has distributed geothermal heat pumps. There's no natural gas connection. So we took the money we saved from not building a gas line to the building and put that into things like solar panels on the roof and a higher performance building envelope. And if you want to come see this building, actually the Renew ride is this Sunday, and we're going to be touring the building on the ride. All right, so I live in Madison on the near west side, and I commute basically from Madison to Middleton to get to work. And I started thinking about all the heat pump buildings that are just in essentially this 3-mile stretch. It's hard to know like what's a heat pump building, what's a natural gas building, but there's heat pump buildings all around, and they've been being built for many years. So First Unitarian Society, their addition is a central geothermal system. Actually, I think Janice is on the call. She's a member there, so thanks, Janice. 800 U-Bay Drive, that's a UW Health building. That's an air source heat pump VRF system. My dentist's office, which is a CRUP development, is VRF system. As you go further down the road to, this is Slipstream's old building. I think Jeanette's on the call, so thanks, Jeanette. This is Krupp and Potter Lawson. This is a geothermal VRF building, so super cutting edge and a very high performing building. And then further down University, you have the Roland Reading Center, which is a air source heat pump system that was put in, I don't know, probably close to 12, 13 years ago. We work with a lot of schools within Wisconsin, and these are just the schools we've worked with in the last couple of years on new construction, installing geothermal heat pumps and designing the geothermal field. So school districts all over the state are going geothermal because they know that it's a long-term investment in reducing their carbon footprint and lowering their long-term utility bills. Okay, so the next few are for retrofits. We could retrofit existing buildings with heat pump technology. So this is SC Johnson campus in Racine. They just added on a bunch of new square foot, but they also renovated their old square footage, including this existing Frank Lloyd Wright buildings, with a central heat pump system with some supplemental gas boilers. So this is super exciting development, and we're involved in the commissioning of this system, and it replaces their old central steam boiler system. METC Mequon. This is Milwaukee Area Technical College. This is their Mequon campus. They're just finishing up a conversion of their natural gas boilers to a central geothermal system. And they also installed a bunch more solar PV at the site. Okay, the next two examples are heat pump systems, but they're using a unique source for heat rejection for essentially the water loop. So in this case, this is the River Heath development. We toured this a few years ago with the Renew ride. We're actually utilizing the river water here. This is the Fox River that goes by the development, and we have some heat exchangers in the river flow, and that's essentially our ground source water. So instead of geothermal, we're actually using the river, and we could do that because there's a hydro dam just upstream of the facility, so we always have good water flow and no ice in this section of the river here. This is the Madison Sewer District maintenance facility. We were involved in this project as well, and this facility actually uses the wastewater effluent as the water source for the heat pump. So this is at the site of the wastewater treatment facility. They take their clean effluent water, and a small portion of it runs through some heat exchangers to help maintain our loop temps in our building for our heat pumps. There's some emerging technology around heat pumps that I won't get into. Some of these are a bit more far-fetched than others, but one technology is using groundwater, using a well for your water source, and then re-injecting that water back into the ground. So that's not legal in Wisconsin, but in other states, it's a commonly practiced method to provide for a consistent temperature water loop for your heat pumps. There's some ideas out there and some demonstration projects to use the municipal water system as your water loop. So for example, in my house, I could take my domestic water that I get from the city and run that through a heat pump with like a double wall heat exchanger, and then put that back into the water system at a slightly higher or lower temperature. And then community geothermal is another emerging idea out there. All right, so in closing, I got this Wayne Gretzky quote here: "I skate to where the puck is going to be, not where it has been." And I think this is a super apt quote for heat pumps and seeing where the grid is going and thinking about, the technologies that we're putting in today are going to be there for the next, 30, 40, 50 years. And it's quite difficult to retrofit a building designed for really high temperature hot water that we typically see with natural gas boilers. So that's my plug for heat pump systems, and looking forward to hearing more about geothermal.
Thank you so much, Mike. If you could hand over controls back to me,
Yeah.
I can set Scott up here shortly.
There you go.
Perfect. Thank you so much. All right, Scott.
Okay. Hey, thank you everybody for being here. Clearly, I'm in a little bit of a different position than most of you, but just to give you a little background, I'm physically on the ground installing these systems in 4 states throughout the Midwest: Minnesota, Wisconsin, Michigan, and Illinois. And this is just an overview from one perspective. Specifically, as I worked on this, we were looking at what are the barriers in Wisconsin that can help accelerate adoption. But please feel free to reach me anytime. Next slide, please. Thank you again to the Wisconsin Geothermal Association and Renew Wisconsin. For purposes of this presentation, as I mentioned, I feel humbled by all of your colorful presentations. I'm afraid most of mine is going to be in written form, but the ideas are still the same, and I'm more than willing to talk in greater detail than what this presentation has alone. We're going to look at the utilities perspective and why heat pumps are good for Wisconsin. We're going to look at the consumer, the educational and technical aspects of this, as well as policy opportunities, because what we are seeing, next slide, please, is fundamentals and definition that are not fully defined. And I hope to flush that out in this presentation. So first of all, from the utility perspective, I am talking specifically of ground source heat pumps. and they do eliminate fossil fuel combustion on site. They eliminate the need for redundant infrastructure. By that, I mean delivery of natural gas systems and or other delivery. They offer the highest efficiencies, up to 500% efficiencies in heating mode, and the highest efficiencies in cooling mode as well. You can have backup heat if you choose to. That is a design choice. I tend to lean toward the design of 100% for the geothermal system, but others, to get that first cost down, will design for something less than 100%. The extreme reliability of geothermal systems, because all we're doing is moving energy, we're not managing ignition and burn temperatures. We have over a 24, 25-year rated life through ASHRAE, which is the American Society of Heating and Cooling Engineers. The life of the machine itself is that 24.7 years. I frequently am changing out systems that are 38 years old, because again, all we're doing is moving energy. We're not managing high temperatures and pressures. The external portion of a geothermal or ground source heat pump has a rated life now of over 100 years. Again, that is a polyethylene material that's fused together with a fusion process. We're seeing that extensively. A key going forward will be keeping mainstream affordability. And that today has been accomplished either through long-term thinking. By that, I mean return on investment over longer periods of time than most investors are used to. In my experience, most investors are looking at 3 and 5 year horizons. We need to look at the lifetime value of that building itself. We build buildings for lives rated at 200 years frequently here in the United States, and even longer in Europe. So we're looking at what is the life of that system overall. And when you look at that, there is no less expensive way to provide your heating and your cooling and your hot water than through geothermal ground source heat pumps. Next slide, please. Consumers love geothermal heat pumps because they're comfortable and reliable and safe, and of course, very environmentally friendly. In fact, the US EPA has defined it as the most environmentally friendly, cost-effective, and energy-effective heating, cooling, again, and hot water technology. They're quiet. They sound similar to your refrigerator, for example. It is a refrigeration technology with very small amounts of refrigeration in them when you're talking ground source. Air source heat pumps, which I frequently hear people using the term heat pump generically. We really do have several different segments of heat pumps, and I thank other presenters for presenting that as well. But the energy efficiency is unquestionable when we're using the earth itself as our battery, and we're circulating our water through that loop in the ground or that geoexchanger, and then making the actual transfer inside the home with an electromechanical device. Next, please. So again, I may have misread my audience here. You guys are all very well informed, but I want to make sure that some fundamental definitions get clarified. Geothermal by itself is an energy from the earth. However, if you do some research on it, you're going to find several different forms of geothermal popping up, of which one of them is relevant here in Wisconsin today. Now, hot rocks, for example, is a little bit like Old Faithful, where we have steam coming out of the ground, turning a generator, creating electricity. That is very site specific, but it is a great source for energy as well. Hot spas, etc. I recall one of us being from Boulder, and clearly some of the hot spas there are interesting. Again, not available in Wisconsin. What is available in Wisconsin in almost an unlimited basis are ground source heat pumps. Once again, we're circulating water through an electromechanical device, and we're moving the energy as opposed to igniting and combusting. To give a little visual representation of that, I'm just going to use a house, but to HVAC engineers and people in the HVAC industry, a BTU is a BTU. So whether it's a full-scale large apartment building or a home, the process is the same. For example, in cooling, the home is warm. We're going to take that warm air that's in the home, and we are going to relocate it to below ground through the ground source heat pump. Likewise, in the wintertime, we're going to collect that typically 50-degree earth temperature, and we are going to concentrate it and provide all that heating, all that hot water during the wintertime. Next slide, please. Heat pumps. Again, the generic term heat pump is in every technical resource manual that I've seen in every state. Why it's not specifically identifying geothermal, air source, ground source, water source. Here are really what the four main types are. Your air source heat pump, in a generic term, has been our traditional air conditioner systems, where they are added outside the structure. There's an A coil above the plenum of the furnace. The furnace is providing the blower motor, and we're passing air across a coil that is cooled through the refrigeration process. The advanced air source heat pumps today, mini splits, VRF, some call them ductless. The big brands out there are your Mitsubishis and your Daikins, Panasonic. You could go on with many other names, Carrier, etc. But they're using a slightly advanced technology that is allowing for both heating and cooling. Okay, but understand that type of air source heat pump has a rated life of about 15 years. And it typically has long line sets. What is a line set? In HVAC terms, our line sets is the refrigeration. So if you are running a refrigerant throughout a building with long line sets, you're talking about hundreds of pounds of refrigerant. The other types of heat pumps, water source heat pumps, are typically what we see in apartment buildings, where we're truly taking the heating dominant portion of a high population density, and we might be moving heat from one area to another that needs it. We might be moving cooling from one area to another. We may have a rooftop system that is also helping to dissipate that heat in a water source situation. The ground source heat pump, again, is what I'm referencing for the most part and what I'm most involved in. This is where we have a ground loop heat exchanger combined with electromechanical devices inside the equipment. The largest ground source installation in the world is EPIC, located in Verona, Wisconsin. But understand how the testing methods are done by the various engineering societies. When you look at energy efficiency, typically COPs, or coefficients of performance for heating, and EERs, energy efficiency ratios, or SEER, seasonally adjusted energy efficiency ratios, are used. The seasonally adjusted energy efficiency ratio and the COPs for an air source heat pump are tested in the best possible condition. That published data is the best possible condition, meaning 70-degree entering air, compared to a ground source heat pump, which is tested in the worst possible condition. This is the published data that people sometimes use for comparison. And when they do that comparison, you need to be absolutely clear that you're not looking at apples to apples. It's more like apples to oranges, because 30-degree entering water without freeze protection is fundamentally ice. And so your ground source heat pump is heating by using ice, right? In that worst case scenario, the efficiency of the system goes way up when you improve that incoming water temperature. Next slide, please. So how do we optimize these technologies? And again, I really appreciate the presentations that others have put together here today. I always learn, and we are all always learning, and the technology is always getting better. More and more, we need internet connectivity to everyone, available everywhere, country, city, it doesn't matter. We need that availability as HVAC pros in order to manage the lifetime operating system. Okay, the total lifetime cost is the goal line metric when you ask yourself about housing. Now, how do we optimize that performance? Let me make a couple of other comments, and I'll come back to a system that actually does this. The utilities, again, are motivated by providing exceptional service and reliability, along with clean energy. A lot of the investors today who invest in the utilities are demanding of these utilities that they shift their mix over to more green energy. And we do need these utilities in many cases, primarily for the base load. Whether we make the complete conversion to 100% renewable or not, in many cases, we are going to need that base load for a long time. Manufacturers are motivated to help drive down costs and make products more affordable, while at the same time driving up performance and adoption, right? Contractors, this is a key part that we need to really go to work on. We need skilled people who really understand refrigeration, who really understand how to move air and how to move water. They sound kind of fundamental in their basics, and they really are, but we're not teaching our children who are coming up, and I mean teaching at levels K and all the way up to K-12. We're going to need to know a lot more about how to work with pumping solutions and air movement solutions than what we are teaching our middle school and our high school students today. I do believe it begins there. I do believe a lot of the apprentice opportunities are getting better and better. The apprentice programs have been key to our infrastructure for a long time, and we need to enhance that education opportunity. And finally, consumers, they're demanding more cost-effective solutions without reliability give-ups. Next slide, please. This is an example. Smart technology is kind of a generic term. And once again, we have to be careful with our terms because smart technology to one person is different than smart technology to another. This is an example of an energy and refrigeration monitoring system. This is an older slide. I think we're probably over 10,000 installs at this point. But throughout the United States, what we're monitoring here are ground source heat pumps. And this is where a consumer chose to pay the added cost of putting this system in, or the contractor saw the benefit to putting this in terms of their long-term value proposition to their customers. But what they are monitoring is the heating, the cooling, the total cost of operating this system. Now, likewise, this is why the internet connection is so important. We can monitor the operating parameters. Actually, this system monitors 110 different parameters of that electromechanical device. And what that means is that we can provide some fundamental service without ever getting in a vehicle and driving to the site and working on diagnostics. So from a service standpoint, we can service this equipment remotely and or diagnose remotely and make one trip to the facility if there is a parts change or an improvement required on site. This kind of energy and refrigeration monitoring technology is really pretty basic. I mean, we have Elon Musk here flying rockets up into space and then bringing those rockets back. Now that's an advanced telemetry. This is kind of fundamental telemetry. And I really ask myself, and I ask all of you, why aren't all the HVAC companies putting this in their equipment, right? If we can gain efficiency, if we can lower operating costs, we can lower lifetime operating costs, we can monitor that the machine is operating properly, why wouldn't Daikin, Mitsubishi, Carrier, all these major players, why are they not putting this equipment? Why aren't they fitting this equipment with energy and refrigeration monitoring? I really don't know, but here's an opportunity for us down the road. Here's an example. This is happening in some cases. It could happen in a whole lot more. Next slide, please. Oh, and I'm sorry, if we can step back to that slide, I had one last comment here. So we're looking at ground source heat pump on an average with these 7,300 installations, $54 a month for all your heating and cooling in your house. That is a pretty reasonable cost, particularly in some of our northern climates or southern climates where we have extreme temperatures. Next slide, please. All right, investments. Really, the key is education. And when I say education, I mean fundamental knowledge of working with your hands and doing brazing, operating a torch, operating pumps, electrical wiring. This kind of grassroots technical understanding is something America was founded on many years ago. And unfortunately, many of our grade schools and high schools today hardly even have a shop class. So once again, we have an opportunity to step up and teach the hands-on necessary skills for these kinds of systems. In addition to that, we need to be sure about the terms we're using when we're communicating amongst engineers, architects, builders, you name it. If we're talking about heat pumps, are you talking about an air source heat pump? Or are you talking about a ground source heat pump? We need to be crystal clear about that, not only in our conversations as professionals, but in our technical reference manuals, state by state, which is used by many of our energy engineers to set up the incentives, right? Once again, the lifetime value is the ultimate metric. If we want if we want consumers both to be comfortable and to have the lowest possible cost, we need to evaluate those lifetime costs. And that may in fact be a system such as this, but it certainly includes the frame of the structure and how that structure is all put together with its insulation and its windows, and it's that total look that will give us the value we're really after. Next, research and development. We have programs going on. There were some mentioned in some earlier about low-cost ground loop installations. We have many ground loop installations, but we also are now and more seeing these microgrid type systems. In other words, an entire community may go off of a single grid, may go off of a single ground source loop. This is becoming very popular in some areas, and it's a big opportunity going forward. But how we proceed in developing the professions is going to be critical, both in terms of the designers and the engineers, but also in terms of the technicians who physically are on the ground putting this equipment in. Financing policies. For years, we have seen financing accelerate adoption of solar. That is a great thing for all of us, I believe. For example, low-cost financing has led to a number of very large ground source heat pumps. In the state of Georgia, I believe it is now completed. 5,500 homes are on a single geothermal loop. In Texas, 7,500 homes are under construction on a single loop. And in New York, 9,500 homes on a single loop. Now, the interesting part about New York is the company installing the ground loops are the utilities, and the utilities simply charge a monthly rate for being connected to the ground source loop. But they have a set group of people who are very skilled at putting pipe in the ground. Instead of putting natural gas pipe in the ground, they could be putting a ground source loop in the ground. And that, in fact, is what is taking place today in New York. And we in the Midwest can learn from our friends and our neighbors. State classifications of ground source heat pumps. The definition is renewable energy. Let me say that again. The definition federally of geothermal ground source heat pumps is renewable energy. We have yet to achieve that classification, or I should say it was once achieved and then it was reversed. And right now we're lumped in with an energy efficiency descriptor. Okay. Clearly the BTUs we're extracting from the earth, with the earth being our battery, is renewable energy. And in some cases, our state legislation may not catch up, right? We also have some elderly legislation within the laws within Wisconsin that deter fuel switching and or the promotion of fuel switching. We'd like to see some revisions to that, and it is an opportunity to grow further. Bottom line is we're going to need a whole series of different skill sets among workers, and we're going to need to continue to grow along the technology lines, as well as put pressure on the various providers of this equipment to be accountable for just how operational and how much we can monitor this equipment on a remote basis. Next slide, please. So that concludes what I have to say. Again, I'm amongst some great presenters. As you can see, I have a lot to grow in that area, but I love your colorful pictures. If you have any questions or I can help you, please let me know. But the ground source heat pump technology is very different from a traditional heat pump. I really wish we as professionals in our industries could begin to speak in terms of what the technology actually is. Where is the source of the energy? And keep in mind what I said about air source heat pump versus ground source heat pump. The entering air temperature for an air source heat pump is 70-degree air. That's the best case condition. I recently had a major manufacturer of air source heat pumps on stage in front of a large audience of contractors. And he was asked, what is the COPs of that equipment at 12 degrees Fahrenheit? He did not answer twice. Third time he answered 1.000007. In other words, many of these cold climate air source heat pump technologies are really running electric strip below 12 degrees. So let's just be clear about the terms, and let's evaluate and publish accurately the efficacy of this different equipment. Again, thank you.
Thank you so much, Scott, and the rest of our presenters. It looks like we are over time. However, if anybody does have questions, I see quite a few people still online right now. So if our panelists wouldn't mind just answering a couple questions, maybe generally. Take a look here in the chat. It looks like some of the questions might have been answered in the Q&A already. Looks like they all have been answered in the Q&A. So take a look at the Q&A. Thank you, Lauren and Mike and others who went through and answered those questions. I really appreciate it. I'll check the chat really quick as well. Otherwise, always know that we are sharing these slides and the recording, or this presentation has been recorded. We can share those with everyone, and you can always follow up with our presenters as well. But if nobody objects, maybe I'll find a question out of our chats to read really quick to the panelists, and you can handle this according to whomever feels like they can best address the question. Here's one we saw popped up earlier. Is the energy load on a family in a rental situation being addressed by grants? Is this something that's currently being explored? And I'll kick that over to the panelists if that's something you think you could handle. It might be something, Marnese, it sounds like you were talking about grants earlier. This might be something that you could field.
Can you repeat the question? I was thinking about it.
Yeah, sure. Is the energy load on a family in a rental situation being addressed by any grants that you're aware of, or anyone else on the panel as well?
I haven't heard any, but I know they have like the weatherization programs or light heat programs at the state level, depending on your state. They can have like their utility bills paid if they go over, or they can have their home either weatherized or have an energy audit on their home. I know that's how it is in Michigan, but every state is different. So I haven't heard of any like real grant programs where they will actually receive the money themselves.
Sure. And if anyone else has anything to add to that as well, we can certainly address that. Otherwise, it looks like we have one of our attendees has his hand raised. We can go ahead and maybe you can just ask a question out loud. Hi, Don, if you can hear me, feel free to, you should be able to speak now. If you could just unmute yourself, you should be able to ask your question.
Okay. Sorry, I raised my question my hand by mistake. I had all my questions answered. Thank you.
Yeah, thanks, Don. I appreciate it. So take a look in the Q&A if you haven't had a chance to. It looks like Lauren and Mike and some of the others might have answered a lot of the questions. If nobody has any further questions, I think this might be a good breaking point. As always, we will share the slides with everyone as well as the recording. Thank you again to all of our presenters. And if anyone has any follow-up questions for them, their contact information is on their slides as well. Thank you. I appreciate it. Take care, everybody.
Thanks a lot. See ya.